Einstein was a pretty smart guy. Despite everything about E equals mc squared and the photoelectric effect, which he won the Nobel Prize for, his biggest contribution was probably his theorems of general and special relativity. They were groundbreaking at the time and still relatively mind-bending now. While most people aren't completely familiar with it, chances are you've heard it referenced. If you've heard anything about black holes, space-time, or light cones, you've heard about Einstein's theories. The best example of which in pop culture is probably the 2014 movie Interstellar, where a majority of the movie occurs near and, spoiler alert, in a gargantuan black hole. I absolutely love the movie, going as far as making a remix of the main theme, which is currently my most viewed video. I'm not sure how to feel about that. This is a science channel. Anyways, back to the video. Put simply, general relativity is all about gravity and special relativity is all about space and time. The two together form a relationship between space, time, light, and gravity. That was just a list of things. Okay, let me put it in greater context. In 1905, Einstein came up with a paper called On the Electrodynamics of Moving Bodies. Basically, it called into question the relationship between Newtonian physics and Maxwell's laws. The specifics aren't important, but essentially Einstein figured out that they don't work together. Big brain that he was, he proposed special relativity to help them work out. He discovered that when an object approached the speed of light, or universe's intrinsic speed limit, our classical physics starts to break down. Newton's laws don't really work. It isn't noticeable when talking about slow objects, but that's the thing about laws. They only need to be wrong once to be wrong. When approaching the speed of light, space and time became two heads of the same coin, and so was born space-time. Einstein's new creations were great, until that is another issue: gravity. Special relativity really helped, but it itself broke down near massive bodies. Further flexing his superior frontal lobe, Einstein then created general relativity. It introduced the warping of space-time, and how that is what gravity was. Light was influenced by gravity and influences other objects. Everything's gravitational force was merely a dimple in space-time. Space itself stretches and time slows near massive objects, and time itself stops at a black hole. Does that make sense? No, of course not. How would time stop? How would something without mass have gravity? Yet, these are what Einstein predicted, and for the most part, they were really accurate. So accurate that they're still used as the best explanation for gravity and space-time today. Now, Einstein's equations do have a few problems. The biggest problem in physics today is creating a theory of everything, something that explains every single interaction in the universe. So far, we have two big parts of the puzzle: quantum field theory, which explains really small stuff, and relativity, which explains big stuff. The problem is, they don't work well with each other. We're still missing a piece of the puzzle, and it's incredibly infuriating. However, new progress is made every day. For example, on April 7th this year, some monumental news was heard. The muon G2 experiment recently provided evidence that we may be missing some elementary particles. Yet more pieces to this puzzle to solve. I'll be anxiously waiting for the TOE's development from here, and hopefully one day joining the search. Thank you, and thanks for watching.